Hi, my name is Lewis Piper. I'm an assistant professor in the physics department at Binghamton University, which is a state university of New York school. Here we have our XPS system, our X-ray photoemission spectrometer. This is also known as an electron spectrometer for chemical analysis, commonly called an ESCA. The X-rays are from our aluminum K-alpha source, which are monochromated, are directed onto our sample, and then the emitted photoelectrons are detected with our analyzer. This system is primarily used to determine the chemical composition of solids. We are doing our measurements in ultra-high vacuum. So the pressure difference between here, which is atmosphere, so say 1,000 millibar, inside here we're talking of the region of 1 times 10 to the minus 10 millibar. This is why we see our chamber has these thick pieces of stainless steel, because it is holding the pressure difference. So we can see that our system is comprised of sections which we can isolate as different parts. So here we have isolated the chamber and we have these gate valves. These separate our chambers so then we can maintain different pressures. This is our main chamber, and we always try and keep it in the best ultra-high vacuum conditions that we can. So this is trying to get base pressures of 1 in the minus 10 millibar. Here we can see us separate the chamber with a dedicated load lock. And this part here is where we can close and protect the vacuum on this side in our main chamber, and we can vent this to a dry nitrogen environment where we have a small volume. We can put our sample in, close, pump back down, and our turnaround is very quick. In addition, a lot of the pieces of equipment are very sensitive, and so we do not want to expose them to water or even high pressures, especially if they were running a bias. They may get damaged. In addition, this particular piece, we have added on a dedicated surface preparation chamber. As I mentioned, we are measuring from photoelectrons that primarily come from the topmost layers. We're talking, in this case, our effective probing depth is something like 5 nanometers at most. We can make it more surface sensitive, but we're limited to that topmost 5 nanometer region. So we have a dedicated surface preparation chamber where we can clean our surfaces because whenever we insert our samples into the chamber, they are going to be exposed to atmosphere. They'll have hydroxyl, hydrocarbon species on the surface. And because we're surface sensitive, we'll be measuring them rather than our solid. We also have a separate load lock system, so then we can load samples independently into the surface preparation chamber without affecting experiments in the main chamber. The main chamber consists of both a depth profile sputter gun, a UV source, X-ray photoemission analyzer, which we can see has its characteristic hemispherical shape. Then on the top here is our controls for our X-ray source, which is aluminum K-alpha. It is monochromated, so then we can make sure that we have a small source of incident radiation.